Hey guys, today we're going to review graphing linear inequalities. So here is a linear inequality, y is greater than or equal to negative 3x plus 5. We're going to start by testing whether the coordinate point 2, 9 is a solution. So we go ahead and plug the x and the y values into our inequality. And we're going to see, is 9 greater than the right side? Well, the right side simplifies down to negative 1, and 9 is greater than or equal to negative 1. Therefore, 2, 9 is a solution. Again, we can test another point, 5, 3. Similarly, we get that 3 is greater than or equal to negative 10, which is true. This leads us to see that there are more than just one or two solutions to every inequality. So if I were to graph this inequality, y is greater than or equal to negative 3x plus 5, it would look like this. And here is our point 5, 3. The shaded region is all of the solutions. So there are thousands of solutions. There's actually an infinite amount of solutions in this shaded region. Here's just one of them that we tested. Our other one was 2, 9, and it's just off my graph, but it is still in the shaded region. So when we talk about linear inequalities, know that there are an enormous amount of answers that satisfy our inequality, and we're going to practice shading those regions. So some steps to graph a linear inequality. Our first one, we're going to graph the related equation. Instead of seeing an inequality sign, we're going to act as if it's an equal sign. And we're going to plot points like we would for a regular equation. If we have a greater than or less than sign, we're going to connect the points with a dashed line. If it's greater than or equal to or less than or equal to, it would be a solid line. And our last step is to shade one side of the line that's going to indicate our solutions. So we'll go through a couple examples. We're going to graph 5y plus x is less than 20. So in order to graph this, we need to solve for y. So I subtract x and then divide by 5. When I graph my inequality, we go up to 4 and then have a slope of negative 1/5. Okay. Since it's strictly less than, we have a dashed line. And then in order to see where I should shade, I chose the easiest point on the coordinate plane, which is 0, 0. And I went ahead and plugged that into this inequality. So I tested 0, 0 down here. We want to know, is 0 less than negative 1/5 times 0 plus 4? Well, 0 times anything is 0, so 0 plus 4 gives me 4. Is 0 less than 4? It is. Therefore, this origin needs to be in my shaded region. So I shade this bottom part of my line. 0, 0 will always be a good go-to testing point unless the line goes through 0, 0, and then you can pick another easy point like 1, 1 or 2, 0. But I would recommend using 0, 0 as your test point unless your line goes through that point. So here's another example. We have 3y plus x is greater than or equal to negative 9. So again, subtract x, divide by 3, we get y is greater than or equal to negative 1/3 x minus 3. I went ahead and plotted that line. This time, notice my line is solid because it's greater than or equal to. But I want you guys to go ahead and test 0, 0 and tell me whether we should shade that 0, 0, if we should shade the origin side or shade the opposite side.